By the end of this lesson, you should be able to explain the effect of increasing or decreasing time of impact on the magnitude of the impulsive force. Describe situations where an impulsive force needs to be reduced and suggest ways to reduce it. And describe situations where an impulsive force is beneficial. Observe the animation. Describe what happened to the two cars. Both cars were moving with the same velocity. The red car crashed into a tree and was severely damaged. The blue car crashed into a pile of sand and was not as severely damaged as the red car. Why was the blue car less severely damaged than the red car? The impulsive force acting on the blue car was smaller because the pile of sand increased the time of impact. A car of mass 1,000 kilograms travels with a velocity of 50 meters per second. The car crashes into a concrete wall and stops. What would the impulsive force on the car be if the time of collision is 0.01 seconds? We know that mass of the car, m, equals 1,000 kilograms. Velocity of the car before collision, u, equals 50 meters per second. Velocity of the car after collision, v, equals 0 meters per second. The impulsive force exerted on the car if time of collision is 0.01 seconds is 5 million-newtons. The negative sign indicates the impulsive force exerted is in the opposite direction to the motion of the car. What would the impulsive force on the car be if the time of collision is 0.1 second? We know that mass of the car, m, equals 1,000 kilograms. Velocity of the car before collision, u, equals 50 meters per second. Velocity of the car after collision, v, equals 0 meters per second. The impulsive force exerted on the car if time of collision is 0.1 seconds is 500,000 newtons, that is, 10 times lower than if t is equal to 0.01 seconds. What would the impulsive force on the car be if the time of collision is 1 second? We know that mass of the car, m, equals 1,000 kilograms. Velocity of the car before collision, u, equals 50 meters per second. Velocity of the car after collision, v, equals 0 meters per second. The impulsive force exerted on the car if time of collision is 1 second is 50,000 newtons, that is, 100 times lower than if t is equal to 0.01 seconds. The table shows the effect of time of collision on the magnitude of the impulsive force exerted. Collisions involve huge impulsive force and cause damage to the car and injuries to passengers. One way to reduce the damage and injuries would be to reduce the impulsive force. This can be done by increasing the time of collision. There are many situations in which we try to minimize impulsive force. Why does the goalkeeper in a football game wear gloves and curves his palms inward when catching the ball? Both actions increase the contact time, thus reducing the impulsive force exerted when the ball collides with the goalkeeper's hands. Why does a high jumper land on a mattress? The soft nature of the mattress lengthens the time of collision, thus reducing the impulsive force exerted on the jumper. Why does the boy bend his knees? By bending his knees when he lands, he lengthens the time of impact, thus decreasing the magnitude of the impulsive force. There are also situations where the impulsive force is beneficial to us. Let us examine some examples. How should we hit a nail with the hammer? Why? The hammer should hit the nail fast and hard. This will drive the nail further into the wood because the impulsive force exerted is large due to the short contact time. How should you pound the nuts? Why? The pestle should hit the nuts fast and hard. This will shorten the contact time, thus increasing the impulsive force exerted. How should you staple a thick set of papers? The stapler should be hit fast and hard so that the time of collision is shortened, thus increasing the impulsive force exerted.
Complete the crossword puzzle. In a boxing match, an analysis was done to determine the impulsive force and the time of impact of 5 punches by a boxer. It was calculated that the boxer has engaged an almost constant impulse or change in momentum to each of the punches he lashed out to his opponent. Complete the table. Which do you think will be the knockout punch?